Hello student, in today's video we will see how we basically calculate a range of any function. So our topic today is range of a function. So suppose your function is y is equal to fx. So let's take an example, y is equal to x minus 1, x minus 2. So here your variable, independent variable is x and your dependent variable is y. So you basically keep changing x and you get value of y. So for this function, if I ask you what is the domain of this function, so domain of this function is equal to r. Here the denominator cannot be 0, so it will be r minus 2. But if I ask you to find the range of this function, so what is the method to find the range of this function? So in case of range of function, what we do, we basically convert this function x is equal to function of y. So what we try to do, we basically put x here and all y on the right side. So let me show you how I am doing this for this question. Y is equal to x minus 1 upon x minus 2. So it's, if you cross multiply, yx minus 2y is equal to x minus 1. Yx, put this x here and y that side, so 2y minus 1. Take x as a common, y minus 1 is equal to 2y minus 1. Now this has become x is equal to 2y minus y upon y minus 1. So here you see very clearly that this function has been converted with the variable as y and dependent variable is x. So here the function is x is equal to function of y. Okay, after getting this thing, after converting in this way, what you have to do, now you have to basically find the domain of this function. So for 2y minus y, 2y minus 1, y minus 1, the domain of this will be r1, r minus 1. So this basically becomes, whatever the domain of this function, that becomes range of this function. So in case of range of this function is equal to r minus 1. So in a nutshell, what is the algorithm? Basically, your function is given y is equal to fx. You have to convert this function as equal to x is equal to phi y. Okay. After converting into phi y, just find the domain of this function. Whatever the domain of this function, this will become the range of this function. So this is the first method. Let me explain the second method. In the second method, basically how you can find the range, you can plot the graph of the function. If you plot the graph of the function, then you can also find the range. So second is basically by graphical method. So for graphical method, you have to basically plot the graph. So in some cases, what happens, you will be able to plot the graph. So there is basically methodology, basically how you can plot the graph of many functions. So I will take another session for that. Basically that is called the graph transformation. So in that session, you will get to know how you can plot basically complex graphs. But here let me take one very simple example. Suppose your function is y is equal to x square. Okay. So by graphical method, what you do, you basically plot this graph. So here your y is equal to x square. This is very simple question, the graph. So here in this case, you have to find the projection of this graph on y-axis. Projection of this graph on y-axis. So for this point, your projection is, for this point your projection is this, for this point your projection is this. So in this way you have to find the projection. So you see in this case all these points from this side always and this side as well. The projection is coming from this point to this point. So this is y-axis. So all the projection is basically, once it is plotted, then that is the range. So in this case, your range will be 0 to infinity, because on y-axis you see the shaded line is basically above 0 line. So your range is equal to 0 and greater than 0. So 0 to infinity. Okay, let me take another example. Y is equal to x square plus 2. Now you have to find the range of this function. So again, if you try to plot this, so this function will come out something like that. So here the projection of this graph on y-axis is from here to infinity. So this point is when x is 0. When x is 0, this is the point is 0, 2. So your range is basically, in this case, range is 0 to, no, it's a 2 to infinity. Okay, let me take one random example. Suppose your graph is something like that. So this is point 2, this is point 4, this is 1, this is suppose 3, here it is closed, here it is open, and then again 7 to 9, here it is coming 6, and here it is coming 8. So in this case, your graph is starting from this point A to B and again C to D. So in this case, if I ask you to find the range, so range is your projection of AB portion on y-axis. This is the point. Here it is open, so it will be open. Here it is closed, so it will be closed. Again, suppose it is open, it is closed. So here it will become open, shaded portion, then close. So your range will be, by this graph, equal to open 1, 3, closed, union, open 6, 8, close. So whatever the projection of this graph portion on y-axis, that will become the range of this function. So in this method, if you are able to plot the graph of any function, very easily you can determine the range of a function. So when you try to basically solve any question at the competition level, and you have been asked to find the range. So if the function is simple, or you know basically how you can draw the graph of that function, then the best way to find the range is basically first draw the graph and then find the range using this method. Okay, student, in this question we have to find the range of this function. So let me try how we can solve this. So your y is equal to x square minus 2 upon x square minus 3. So the concept is your y is equal to fx is given. Now you have to convert is x is equal to 5y. So how you can do that? See here. If you cross multiply is y x square minus 3y is equal to x square minus 2. If you keep this x square this side, y x square minus x square is equal to 3y minus 2. Take x square common. So it is y minus 1 is equal to 3y minus 2. X square is equal to 3y minus 2 upon y minus 1. So here I am not converting into x. Here it is x square. So if you take x, it will be basically a square root. So you can take that also. So x under root 3y minus 2 upon y minus 2. Now the what concept says? You have to find the domain of this function. So how do you find the domain? So here this function is basically under the square root. So when any function is under the square root, what happens in that case? It has to be greater or equal to 0. It has to be positive. So 3y minus 2 divided by y minus 1 greater or equal to 0. So if you use wavy curve method, which I have already explained in my previous session, so you can watch that video as well. So here the critical point is your 1, y minus 1 is equal to 0. and y is equal to, so it is 1 and then y is equal to 2 by 3. Right side is positive, here it is negative, then it is positive. Okay, and when y is equal to 2 by 3, then it can be equated. It can be equal to 0. So this is your open, this is your close, and this point is your open. So if I ask you what is the solution of this one, so in this case the solution is minus infinity to 2 by 3. It's a open union 1 to infinity. So this is the domain of this function. This will become the range of this given question. So hence the answer will be, in this case, this will become the answer. This is the range of the question. So your option number C is the correct answer.